Trigonometric ratios. Trigonometric ratios are defined as a ratio of the lengths of two sides of a right triangle. So here, if we have this diagram of triangle ABC, and it's a right triangle, the sine, the cosine, and tangent of the acute angle A are defined as follows. The sine of angle A is equal to the side opposite of angle A over the hypotenuse. So if we're looking at angle A, this side, x, is the length of the side opposite, so that goes on top. And then z is the length of the hypotenuse, so that's going to go on the bottom. The cosine of angle A is the side adjacent to A, over here we have y, over the hypotenuse, which is z. The tangent of angle A is going to be the side opposite of angle A, our x, over the side adjacent to angle A, which is our y. So what we need to do is make sure we know the ratio for the sine of A, the cosine of A, and the tangent of A. To help us with that is this acronym SOH CAH TOA. SO means sine equal to opposite over the hypotenuse. CAH stands for the cosine is equal to the adjacent over the hypotenuse. And TOA is for tangent, and that's equal to the opposite over the adjacent. So if you remember this, the sine of a given angle is going to be equal to the opposite over the hypotenuse. And those are the side lengths. And then we'll have the cosine of an angle is equal to the adjacent over the hypotenuse. And then lastly, you have the tangent of an angle is equal to the opposite side over the adjacent side. So if you remember SOH CAH TOA, this is going to help you a lot. Let's use this diagram to find some of the trigonometric ratios. So again, just to keep in mind, here's our SOH CAH TOA and what it stands for to help us remember. So if I ask you to find the sine of angle A, what I want you to do in the diagram is go ahead and mark off angle A, and we want to label the sides of the triangle from the perspective of angle A. So the side that's opposite from angle A is side J, so we're going to write opposite here. The side opposite from the right angle is the hypotenuse, and then the last side is going to be our adjacent because this one is next to angle A. So our sine, we need the opposite over the hypotenuse. So I'm going to put the opposite side, J, over the hypotenuse, which is L. The cosine of angle A is going to be the adjacent over the hypotenuse. So the adjacent side is K over our hypotenuse, L. And if I ask you to find the tangent of A, that's going to be the opposite side over the adjacent side. So our opposite is J, and then our adjacent side is K. Now I want you to try to pause, label your diagram from the perspective of angle B, try to write these trigonometric ratios, and then check back with me when you're finished. So when you go from the perspective of angle B, you should have labeled K as the opposite side. L is still the hypotenuse because it's still opposite from the right angle, and J is the adjacent side. So when you find the sine of angle B, it should be K over L. The cosine of angle B is J over L, and the tangent of B is K over J. So here we have this diagram, and we need to find the value of each variable. So we're going to use our trigonometric ratios to set up an equation, and then we're going to solve for x and round to the nearest 10. So to help us, I'm going to start by writing our acronym, SOH CAH TOA. And then after that, we're going to go ahead and label our diagram. So again, we're going from the perspective of the angle 36 degrees. So x is going to be our opposite side. 10 is opposite from our right angle, so here's our hypotenuse. And then y, the last one, is the adjacent side. If you notice, we have to solve for both x and y. You can only solve for one at a time. Now each time we're going to have to use the angle 36 degrees, and I suggest using the side length 10 that is given to us. So if we're going to solve for x first, look at the information that we're working with. X is the opposite, 10 is the hypotenuse. So when you look at your acronym, opposite and hypotenuse are used with sine. So I'm going to set up my equation. The sine of the angle 36 is equal to the opposite side on top, which is my x, and our hypotenuse on the bottom, over 10. So the trig ratios help us set up the equation. Now we just need to solve for x. So in order to solve for x, we're going to multiply both sides by 10. So on the left side, we have 10 times the sine of 36 is equal to x. And then we need to put this into the calculator. When we are using the graphing calculator to help us with this, a few steps we need to make sure of. First, hit mode. And in the third option, your calculator is defaulted at radian. Go ahead and move that to degree mode, and then you can go back to your home screen. Then you want to type in exactly what you see here. We have 10 times the sine of 36, close your parentheses, and hit enter. So when we round to the nearest tenth, 5.9 is going to be our answer. So x is equal to 5.9. Now we're going to follow similar steps to find out what y is equal to. So when we go back to our diagram, y is our adjacent. And again, I would use 10 because it's a nice whole number for the hypotenuse. So when you look at your acronym, the trig function that uses the adjacent and hypotenuse is going to be your cosine. So we want to set up the cosine of the angle is equal to the adjacent side over the hypotenuse. So now that we have our equation set up, in order to solve for y, we're going to multiply by 10 on both sides. So these 10s cancel out, and we have 10 times the cosine of 36 is equal to y. And then again, at this point, we're going to go to our calculator again, and we're going to type in 10 times the cosine of 36 degrees, close our parentheses, hit enter, and we get 8.1 when we are rounding to the nearest tenth, so y is equal to 8.1. Here's another example. I want you to go ahead and pause, try this one, and check back with me when you're finished. So, hopefully you found that x is equal to 3.9 and y is equal to 8.9. When you go from the perspective of the angle 64 and you label your opposite, hypotenuse, and adjacent sides, make sure you're using the angle measure of 64 and that whole number 8 that was given to us each time. So then when you follow the adjacent and the opposite side, you're going to be using tangent. So this is the equation that you set up. Tangent of 64 equals 8 over x. Now, when x is on the bottom, your algebra skills need to kick in. Multiply both sides by x, and then to isolate x, you have to divide both sides by the tangent of 64. Now, when you set up your equation for y, it's going to be very similar to that. The hypotenuse and opposite uses sine, so you set up sine of 64 equals 8 over y. Then again, your algebra skills need to kick in, where you multiply both sides by y. Then you have y times the sine of 64 equals 8. And to isolate y, divide both sides by the sine of 64. And both of these you can type into the graphing calculator just the way I showed you, and then round your answer to the nearest tenth. That's all for this lesson on trigonometric ratios. I'll see you in class for more practice.